All right, analyzing function notes. We have linear functions, quadratic functions, and exponential functions that we've talked about so far this year. Linear functions are y is equal to ax plus b. We've also called it mx plus b, y equals mx plus b, where that is the slope and this is the y-intercept, right? We also have quadratic functions, y equals ax squared plus bx plus c. Remember doing all that with the quadratic formula. And then we have exponential functions, y is equal to a times b to the power of x, right? And that b is made up of 1 plus or minus the rate. You remember all that? A is the initial value. And then we can also have a plus c on the back here that is our asymptote. You remember all that? Good. So what is this going to look like? Linear functions will be a straight line. Quadratic functions will be a parabola. And then exponential functions, it's kind of like a line and a parabola mixed together. They kind of do that. Okay? That shows exponential growth. We could also have exponential decay. All right. So let's graph some data real quick. If we graph these points, we can figure out what it is, okay? Because we look at the shape in order to find out what it is. So at -2, +5, -2, 1, 2, +5, 1, 2, 3, 4, 5. -1, 2, 0, 1, yeah. 1, 2, and 2, 5. Okay, so if we connect all these dots, we can kind of find out what shape that is. And this is a quadratic. You can also look at the values and see that it's going down. Look at the y values. They're going down, and then they're going back up. Okay, so that tells you it must be a parabola. Parabolas are the only ones that go down and then back up, or up and then back down. All right, this one screams exponential function to me right away because of these numbers getting very, very close to 0, but not approaching. So -2 and 1/9 is eh. -1 and 1/3 is meh. 0 and 1 is here. 1 and 3, and then 2 and 9, all the way up here. So this one screams exponential function to me just by looking at the numbers, and it is whenever we connect all the dots and draw our lines. This is an exponential function. Okay, don't forget that you can plug both of these into stat, right? You can do stat, and this one is quad reg, and this one is exp reg. All right, you good on that? Cool. All right, there's a bunch of words here. I didn't want to feel like writing down all the words, but I'll help you fill this thing out. It says above the little box, this is in a little box right here, right? Another way to determine which model best describes data is to look for a pattern. It should say a pattern. If the differences of successive y values are all equal, the data represents a linear function. Linear function. So if the change in y is always equal, then it's a linear function. If the second difference, this one says if the second differences are all equal, but the first differences are not equal. So you remember when we took a section of information, we subtracted all the y data, and then we subtracted all the y data again. That's the second difference. Then that is a quadratic function. That was a long time ago. I doubt anyone remembers that. And then if the ratios of the successive y values are all equal and r is not equal to 1, then the data represents an exponential function. So if the ratios are all equal. All right. So we're looking for a pattern in the table. What we're going to do is we're going to subtract our y values and find out what's going on, right? So if we subtract these y values, -3 minus -8, what's the change, right? -3 minus -8 is going to give me a +5. 2 minus negative 3 will give me a positive 5. 7 minus 2 will give me a positive 5. And 12 minus 7 will be a positive 5. This is the first order of y's, right? That's the first order. If those are all the same, this is linear. All right, now let's look at these. 4 minus 8 is negative 4. 2 minus 4 is negative 2. 1 minus 2 is negative 1. And 0.5 minus 1 is negative 0.5. Well, the ratios, I see them doubling, right? Or halving, getting half as small, half as small. The ratios of these, right, are all the same. Negative 2 over 4, negative 2 over negative 4 is going to give me 1 half. Negative 1 over negative 2 is going to give me 1 half. Negative 0.5 over negative 1 is going to give me 1 half. So those are all the same ratios, which makes this exponential. All right, let's look at this one. This one screams parabola to me. See, it's going up, down, down, up. Okay, let's look at it. Negative 7 minus negative 3. I'm typing this in my calculator just to make sure. Negative 7 minus negative 3 is going to give me negative 4. Negative 9 minus negative 7 is going to give me negative 2. Negative 9 minus negative 9 will give me 0. And negative 7 minus negative 9 will give me positive 2. That's the first order. Remember when I talked about that with the linear equation up here? Okay, well, those aren't the same, so we know it's not linear. All right, but let's do it again. Let's do the second order. Negative 2 minus negative 4. Remember, I'm subtracting second from the first. Negative 2 minus negative 4 will give me 2. 0 minus negative 2 will give me 2, and 2 minus 0 will give me 2. When the second order is the same, this whole thing must be quadratic. Okay, so first order is all the same, must be linear. All the same ratios, if I divide them, right, then I will get exponential. And if the second order is all the same, I will get quadratic. All right, let's do this one. 7 minus 11 is negative 4. 3 minus 7 is going to give me negative 4. Negative 1 minus 3 is going to give me negative 4. And negative 5 minus negative 1 will give me negative 4. What is that going to be? If the first order is all the same, then it must be linear. All right. Exponential growth and decay, just as reminders, we should be able to find this data and help ourselves. All right. So I'm going to show you how to do this on using the table on this one. But we can also use the calculator and stat to find all this stuff. So we know that it's looking for a certain year. We see that it's either decaying or it's growing, right? Over time, it's increasing. So when x increases, y is also increasing. And what do we see is going on here? Well, let's subtract. 10 minus 5 is 5. 20 minus 10 is 10. 40 minus 20 is 20. 80 minus 40 is 40. Okay? Well, if we look at the first level and see that all the numbers are going to be the same in the second level, right? Do you see this? 5, 10, 20, 40. We know that it must be exponential. It's the same thing that happened up here. 4, 2, 1, 0.5. It's all going to be exponential. All right. So we know it's exponential growth. We know that this is our initial value. That's our A. We know that each time it's going 5, 10, 10, 20, 20, 40, 40, 80. We know that it's doubling. So we know that it's going to be 5 times 2. That's doubling. And then after 15 years, so to the power of 15. 5 times 2 to the power of 15 is going to give me a lot. 163,840. Right? So after 15 years, whatever it says, let's see if I can find it. Table shows book club members. If it doubles every year, how many people are they going to have after 15 years? Too many people, right? 163,000. They're going to have a whole city in their book club if it doubles every year for 15 years. All right. Number 8, the final thing says the table shows the cost of placing an ad in a newspaper. I'm sure y'all have never seen a newspaper before, but you can place ads in the back a long, long time ago. Write a function that models the data and predict the total cost for 50 lines. So you pay by the line, right, in the newspaper. If you want to look at this stuff, find a newspaper, flip toward the back to the ad section. There's little tiny boxes of information, and people could purchase those boxes and pay by the line for the newspaper to print whatever they wanted to print. That being said, we have data that doesn't start at 0. So bring out the old trusty calculator, hit stat, go to edit. We're going to plug in these values, okay? Let's see, it's going to say 5, 6, 7, and 8, because those are our x values, and our corresponding y values are 14.5, 16.6, 18.7, and 20.8. All right, we're going to go back to stat, over to calc, down to, we know this is exponential growth and decay. We know it. It's not linear, or is it? Is it linear? Let's find out. Subtract 16, it says $2.10. Hey, it is linear, $2.10 and $2.10. So each one of these is linear. We're going to go down to lin reg, which is, no, we went down to this one right here, lin reg, and we will find our equation of 2.1x plus 4, and our x is 50. So we're going to do 2.1 times 50 plus 4. Plug that all back in. 2.1 times 50 plus 4, and we get 109. So it will cost $109 even to get 50 lines written in a newspaper. Okay? If you have any questions, let me know. Once again, I'm posting all the videos online on Monday. Have a great, wonderful day. Talk to you soon.